The national forests are public treasures owned by all Americans. Among the crown jewels are the Okanagan and Wenatchee National Forests, located along the eastern slope of the Washington Cascades. These forests span 3.9 million acres, from the Canadian border and scenic Pasayten Wilderness in the north to the rugged Goat Rocks Wilderness in the south. Society is looking for ideas on how best to manage national forests for future generations. Many questions are being asked today about forest management. How have the forests of eastern Washington and Oregon changed over the last century? What goods and services can our forests provide for the future? Can ecosystems with a variety of plant and animal species be maintained in a healthy condition? How does fire play a role in this equation? Are the destructive wildfires that we've experienced recently what we can continue to expect in the future? When looking for answers, it helps to first consider the history of our forests and the effects humans have had on them. For thousands of years, before the 1850s and the arrival of European settlers in central Washington, disturbance by fire was the dominant force that shaped dry forest ecosystems. The first explorers and settlers often wrote about the natural and human-ignited fires they witnessed, and the smoke that hung over the mountains throughout the summer months. In their diaries, many who came to eastern Oregon described the mountains and the blue haze they saw. Smoke from distant fires burned summer long and produced the blue in what would later be called the Blue Mountains. The history of eastern Washington forest is much the same. Many of the fires were started naturally by lightning, but others were purposely lit by American Indians to improve hunting, remove cover that could hide enemies, or enhance growing conditions for berries. These were usually light surface burns that kept the forest floor open and allowed for easy travel. These surveyors wrote in the 1855 railroad surveys in the Stevens Report that there is so little underbrush in these forests that a wagon may be drawn through them without difficulty, forming a striking contrast to the dense thickets of the western slopes. The level terraces are covered everywhere with good grass and shaded by fine, symmetrical trees of great size, through whose open foliage the sun's rays penetrate with agreeable mildness, giving to these forests the appearance of an immense ornamental park. Early accounts describe large pine trees, the forest's open structure, an absence of underbrush and small trees, and a lush cover of grass. But how can plants and trees live and thrive in an environment frequented by ground fires? The fine, symmetrical trees referred to in the Stevens Report were ponderosa pines. Under natural conditions, this was the most common tree in east side forests at mid and lower elevations. Ponderosa pines are uniquely adapted to thrive in an ecosystem with frequent, low-intensity fires. Older trees have few limbs at ground level, so it's difficult for surface fires to climb into the treetops. And their thick, corky bark provides insulation from the heat of flames. While adapted to fire, ponderosa pines will burn if enough needles and dead branches accumulate around them, or if they're surrounded by dense stands of younger trees. However, if fires burn through a ponderosa forest frequently enough, fires remain at low intensities and most larger trees survive. Ground fires killed many of the young ponderosa pine and most of the Douglas fir or grand fir seedlings that sprouted in the grove. This benefited larger trees because the young trees competed for the limited water available. With less than 30 inches of precipitation a year in our dry forests, water can be scarce. Grasses and shrubs found in the understory are adapted to withstand low-intensity fires. Pine grass, buckbrush, willow, and many other plants resprout from roots after the fire burns their above-ground parts. In fact, some wildflowers like lupin need disturbance such as fire to promote germination of their seeds. Buried in the ground, many seeds and roots survive the fire. The following spring, young shrubs, grasses, and flowering plants will emerge from the ashes. Even wildlife species have adapted to survive fires. For example, some can fly or run from fires, while others seek underground refuge in burrows. Many plants and animals have adapted to an environment frequented by low-intensity ground fire. But how do scientists know that frequent low-intensity ground fires burned across our low-elevation eastern Cascade landscape? The answer is found in tree ring and fire scar research. Scars from fires that burned around the base of ponderosa pines record a fire history just waiting to be read. Each year, new growth covers old fire scars. Ecologists cut wedges from the base of a tree to read the record of repeated fires over the life of the tree. By studying hundreds of fire-scarred tree wedges dating back to the 1600s, fire ecologists on the Okanagan and Wenatchee National Forests have found that fires frequented our east side, low-elevation forests every 6 to 20 years. Tree wedges collected on the two national forests show that on average, the first fire scar occurred when the trees were only 3.5 inches in diameter. This tells scientists that fires must have been very low intensity because they did not kill these small trees. Such clues from the past show us that fire has long been an integral force in the disturbance and development of forested ecosystems on the east side of the Cascade Mountains. Much has changed in our forests since 1850, when the first settlers traveled west. Now we must step over many dead trees, and travel is difficult through tight, dense forests. It would be very difficult to take a horse and buggy through today's woods. So why do we have thick stands of pine and fir trees growing where 100 years ago we had open ponderosa pine and Douglas fir forests? The complex answer is related to politics, social values, and the changing science of fire ecology. In North America, frequent fires shaped the landscape over thousands of years. As settlement advanced across the continent, communities in fire-prone areas were vulnerable. Hundreds of people died when fires burned through wooden towns with minimal fire protection. It was natural to view fire as the enemy, and a century of vigorous fire suppression began. As waves of settlers flowed into central Washington, there was a dramatic change in the fire disturbance pattern in low and mid-elevation, dry eastside forests. Frequent low-intensity fire quickly became a memory. At the same time, as more and more people settled in the West, wood became viewed as a valuable commodity for homes, buildings, and transportation. Congress created a system of national reserves designed to conserve what remained of American forests. In 1905, President Theodore Roosevelt greatly expanded these reserves and championed their establishment as the National Forest System, under the management of the Forest Service. The application of scientific forestry practices meant the end of the frontier and an end to indiscriminate burning. A continuous supply of forest products was needed. The expanding population had to be protected, and fire had to be controlled. Forester Gifford Pinchot was put in charge of our national forests. In 1910, Pinchot wrote, "In the early days of forest fires, they were considered simply and solely as acts of God, against which any opposition was hopeless." But today, we understand that forest fires are wholly within the control of man. Following the disastrous fires of 1910, the Forest Service and other federal land management agencies established policies to aggressively fight forest fires. This gave birth to lookout patrols and fire crews. At the same time, Washington State had become first nationwide in lumber production and maintained that position from 1905 to 1935. At least half of the wage earners in the state were dependent on the timber industry for their livelihood, a tradition that continued for years. Locally, the large ponderosa pines were especially popular with loggers because of their size and easy accessibility. Orchardists in central Washington preferred apple boxes made from the wood of large pines. By 1931, more than 100 million board feet of lumber was required annually just to supply the fruit industry with needed boxes. By the end of World War II, national forest timber harvest really began to accelerate to help meet the lumber demands of a booming housing industry and a rapidly expanding economy. In many places, virtually all large pines were harvested from private and public lands. Meanwhile, widespread grazing in the early 1900s removed ground vegetation, which altered forests in two ways. Young trees were more easily established in the bare soil, and fires could not spread as easily without continuous shrubs and grasses to fuel them. Fire suppression, timber practices, and grazing changed the makeup of the forest. The largest, most accessible ponderosa pines and Douglas firs in the lower elevations were selectively cut for their high-quality wood. Small pines, grand fir and Douglas fir, were left standing. An unintended consequence of 90 years of successful fire suppression has been the buildup of large amounts of highly flammable fuels in most mid and lower elevation dry forests. Without the natural thinning from periodic fire, tree seedlings rapidly occupied what were once open spaces. Unlike ponderosa pines, grand fir trees have thin bark that does not protect them from fires. Their limbs are thick and begin at ground level, so flames can climb them like a ladder. Because they grow well in shade, firs grow in dense groves. This makes it easier for fire to burn from tree to tree, killing even the large pines. Today, over 700,000 acres of the dry forest, within the boundaries of the Okanagan and Wenatchee National Forests, are in a dense condition, vulnerable to insects, tree diseases, and high-intensity fires. Recent research has shown that there are from 2 to 20 times more trees in these dry forests than there were prior to settlement. A study in Pendleton Canyon within the Mission Creek drainage of the Leavenworth Ranger District found that there were approximately 30 to 40 large trees per acre in the early 1800s. Today, not only is the composition of tree species different, there are over 200 small trees per acre in the same locations where there used to be large trees.